Dazzling, legendary, the most beautiful planet in the night sky. But secretive Saturn has been holding out on us.
We've learned a vast amount about it, and most of this has been very surprising.
We thought we knew those bodies. We had no idea.
Saturn boils with extreme weather and weird lights. The rings ripple and twist, bullied by over 60 remarkable moons.
They are individual worlds. They each have a story to tell. This is a planetary explorer's dream.
Saturn's moons are the hottest property in the search for alien life.
If there's one place in the solar system I would put a bet that life exists there right now, I would choose Saturn.
And on Saturn's largest moon, we may have already found it.
We have found some curious things on Titan, and it might just be evidence of life.
Saturn, the jewel of the night sky, dazzles with its beauty and scale. It's huge, so big you could fit more than 700 Earths inside it. But don't let size fool you.
One of the more interesting things about Saturn is that it is so big compared to how much stuff is in it that it's actually lower density than water. The old joke is that if you could find a bathtub big enough and fill it with water, Saturn would float, but it would leave a ring.
Other planets have rings, but none so vast and glorious as Saturn's. The journey from the outside of the main rings to the inside edge is 66,000 miles. Yet this vast collection of dust and ice particles is whisper thin, just tens of feet in places.
Saturn's rings are made up of mostly very small particles of ice and rock. Some of the particles are larger, but for the most part, no bigger than grains of dust.
Racing within the rings and orbiting far outside them are over 60 moons made from rock and water ice. They range in size from tiny snowballs to worlds with active geology, liquid water, weather systems, and possibly even life a billion miles from the warmth of the sun.
It's so cold out there. We just thought there'd be nothing there, and we were so wrong. We were so wrong.
Saturn's first shocker, its wild weather.
The storms on Saturn are extremely violent, unlike anything we see on the planet Earth. In fact, Saturn has the second fastest winds in the entire solar system.
These winds race through Saturn's cloud tops at over 1,000 miles per hour, 4 times faster than Earth's strongest cyclones. And lightning bolts flash up to 10,000 times more powerfully than those on Earth.
Everything on Saturn is just so very, very much bigger. I mean, there are weather systems that are as big or bigger than the Earth.
Saturn's ferocious weather is surprising because on Earth, weather is driven by the heat of the sun. It causes the seas to evaporate, creating clouds and rain. Saturn lies too far from the sun to feel the same warmth, so the heat that drives its weather must be coming from somewhere else. To understand this mysterious heat source, we need to go back 4.5 billion years to the birth of the ringed planet. The planets of our solar system emerged from a vast swirling cloud of ice, dust, and gas. The same ingredients can still be found on Earth today in places like Iceland, where volcanic ash mixes with icy glaciers.
So if you want to build a giant planet like Saturn, this pile of raw material here is a great visual analog. There's a lot of oxygen and hydrogen in the universe. That makes water ice. And the stuff initially that made the solar system is basically this stuff here. It's dirty ice, water ice, with a little bit of rocky and metallic minerals left in there, out there in the cold of space.
4.5 billion years ago, a vast cloud of dirty ice particles, shrouded in hydrogen and helium, collapses under its own gravity. And at the center, a new star, our sun, sparks into life. The heat of the new star melts the ice closest to it and blows away the gas, leaving only rocky debris behind. But farther out, icy material and gas survive. A boundary forms, a frost line between the rocky inner cloud and the icy gas beyond.
Once you've fired up that campfire, if you will, what will be left behind in the inner solar system is going to be this stuff, the silicate minerals you make a planet like the Earth from. But far away from the sun, where it's colder, you cross the frost line, and what's out there is still cold enough to maintain the ice behind, and there's a lot of it there. At first you make a sort of a solid core of this material, but when you reach a critical mass, you've got enough gravitational influence to start to directly draw in some of the hydrogen and helium in the interplanetary cloud.
Saturn's huge solid core, now 10 to 20 times the size of Earth, generates relentless gravity and draws in gas. The bigger this gas ball gets, the more material it sucks in. Saturn's massive gravity then gets to work on its fledgling atmosphere, compressing it. And like any gas under pressure, it gets seriously hot. Even today, Saturn's high-pressure atmosphere heats its core to 21,000 degrees, twice the temperature of the surface of the sun. And it's this heat rising up which forms Saturn's distinctive bands and drives its extreme weather.
Saturn's actually rotating very quickly. It's a large planet. It rotates once on its axis about every 10 hours. So as the weather comes up from the interior, it gets smeared out into bands.
And at Saturn's North Pole, the bands do something that at first glance seems impossible.
There is a gigantic vortex, a spinning region of air that's shaped like a perfect hexagon.
You have waves of pressure, density, and temperature that start to interact with each other. And these waves can actually interfere and become one big wave that goes all the way around the planet.
This giant wave settles into a long-lasting pattern because there's no rocky surface below to disrupt the winds that form it.
They form a beautifully defined regular hexagon. It's one of the most spectacular things about Saturn.
Imagine Saturn without its rings. Just a pale globe floating in the darkness of space. With the rings, it's magical.
Undoubtedly, the one thing that captures everyone about Saturn is the rings. It's inspired fiction stories, and it's inspired everyone who's looked at it in the night sky.
When I was 4 or 5 years old, my parents bought a small department store telescope. And I remember looking down into that eyepiece and seeing this perfect jewel of a planet.
There's just nothing better than this. And you can just see the rings going around the planet just perfectly. They're just a gorgeous elliptical racetrack.
From the eyepiece of a small telescope, the rings seem quiet and serene. But up close, it's a very different picture. We know this thanks to a space probe called Cassini and over 10 years of images like these. Ice particles jostle for position like stock cars, traveling inside the rings at hundreds of thousands of miles per hour. These particles range in size from chunks of ice as big as houses to the finest powder snow.
It wasn't until we went to Saturn and stayed there with Cassini that we learned just how fiercely complex it is. you have the gravity of the planet itself and all of these moons interacting with the rings and the moons and the planet. All of these things are sculpting that entire system on scales that are both subtle and gross, and it makes this magnificent crown jewel of the solar system.
As small moons go around inside, the ring particles dance around them in response. We see areas of the rings that get raised up as a moon goes by. Moons will even switch orbits with each other. So there's a lot of dynamic stuff going on inside the rings.
Scientists believe that from time to time, Saturn's icy moons break up, adding new material to the rings. This means that the structure of the rings is constantly evolving. With Cassini, scientists can deconstruct the physics of this evolution, and it's teaching us the rules that make the whole universe tick. All the planets in our solar system evolved out of the same flat disk of dust and gas 4.5 billion years ago. Astronomers see similar disks around young, distant stars, but even with our most powerful telescopes, we can't see planets forming. They're too far away. But Saturn's rings are right on our doorstep, a veritable snapshot of a mini solar system caught in the process of formation.
Looking at the rings, we're looking at the formation of planets or bodies in an arrested state of development. It's like you took the beginning stages of the formation of the planets, but stopped it.
Cassini shows structures forming spontaneously inside the rings.
They don't even need to be tickled. They don't need to be disturbed into forming structures. They form them on their own.
Does this tiny moon, captured in the process of formation, show us how the Earth started its life?
You get something that just happens to form out of random processes, and that mimics what astronomers think they're seeing in protoplanetary disks surrounding other stars in the cosmos around us.
Cassini sees curious propeller-like structures inside Saturn's broad A-ring. They're caused by ring particles washing over tiny hidden moons. The particles collide with the moons, sending them into random, ever-changing orbits, sometimes closer to Saturn and sometimes farther away. Perhaps similar forces influence the Earth's formation around the Sun, pushing it into closer or wider orbits. Saturn's rings also help us understand why planets stop growing. A walnut-shaped moon called Pan sits near the middle of Saturn's A-ring. Pan should be huge with so much ice around to gobble up, but it's tiny, only 20 miles in diameter.
If you have a moon embedded in a disk of ring particles, you might naively think it just accretes ring particles until it grows into a bigger moon. But actually, we find moons create gaps in the ring around them. So Pan has created the Encke gap, Daphnis has created the Keeler gap.
Rather than pulling ring material in, Pan appears to push it away. As the moon passes the slower-moving material outside it, Pan's gravity slings the particles into wider orbits. The faster material inside Pan's orbit is slowed as it passes the little moon, causing it to fall away towards Saturn. This may explain why multiple planets form around stars, instead of single giant planets that eat the whole buffet. For most of history, the only moon we've been able to study up close is our own. Multiple deep craters tell a powerful story. The moon is dead. There's no active geology or weather to wipe away these ancient scars. But what about the moons around other planets, like Saturn? Are they dead too?
Our first assumption about Saturn was that the moons would be like that. Cold, dead, lifeless, relics from the early solar system.
It wasn't until we invented spacecraft that could go to these moons that we discovered how incredibly diverse our solar system truly is.
At first glance, Saturn's moons bear striking similarities to our own. Rhea and Ione display their cosmic battle scars with pride, but here the craters are made from water ice, not rock. Mimas bears a dramatic reminder of a colossal collision.
There's one tiny moon called Mimas, which has a huge crater on it, and it looks so much like the Death Star from Star Wars that when people first saw images of Mimas, they thought it was a joke, that we put a little image of the Death Star in there just for fun. But no, that really is what it looks like.
Other moons are marked by Saturn itself, like Iapetus, the moon with two faces.
Now, Iapetus is an icy cold moon, but one hemisphere is dark and dusty, and the other one is absolutely pristine, clear ice.
This split personality initially baffled scientists. Then Cassini turned its magnetic detectors to this tiny moon.
We now know it has to do with the way dust interacts with the magnetic field of Saturn, coating one side of the moon as it goes around.
Some of Saturn's moons are marked by active processes from within. Take Enceladus, an icy moon barely 300 miles across. Nobody paid it any attention a decade ago. Today, it's a geological rock star. And this is why. Enceladus orbits inside Saturn's outermost ring, the E-ring. The E-ring puzzled scientists because they couldn't figure out how a ring so broad and so diffuse could hold itself together. The Cassini team decided to take a close flyby of Enceladus to solve the mystery.
Did it have something to do with keeping the particles together? What was the connection between the E-ring and Enceladus? Well, now we know that Enceladus is actually responsible for the E-ring being there in the first place.
2005, Cassini captures an astonishing sight. 100 geysers shooting ice particles miles into space from cracks in the South Pole. Enceladus is hurling its guts into space at a colossal rate. As Enceladus orbits Saturn, these icy plumes feed a vast, shimmering halo around the planet, the mysterious E-ring. This icy plume also interacts with Saturn's magnetic field, creating a plasma cloud of charged particles. The particles race along Saturn's magnetic field lines and slam into Saturn's polar atmosphere, raising huge ultraviolet auroras. Geysers explain the E-ring, but how can they exist on a frozen moon a billion miles from the sun? On Earth, geysers form in highly volcanic places where water comes into contact with hot rocks. Enceladus, so small and so far from the sun, should be cold and dead. What heats it is Saturn's gravity.
The source of the heating on Enceladus is the eccentric orbit of that moon. Sometimes it's a little closer to Saturn, sometimes it's a little further away. And that heating on Enceladus from that kneading, gravitationally making the moon stretch and pull, is what warms the interior, causing the activity on Enceladus that we see today.
The gravitational pull of Saturn reaches deep into Enceladus, beyond its water ice exterior, gripping its rocky core. As Saturn's grasp strengthens and weakens, it massages this cold, rocky heart, bringing it to geological life with frictional heat. The heat melts the ice around it, creating a vast subsurface lake. This water jets out through huge cracks in the surface ice. On Earth, where there's liquid water, there's life. Could Enceladus have what it takes for simple organisms to exist?
Once Cassini saw these geysers, the scientists knew they had found something extremely wonderful. They actually changed the mission of Cassini itself, changed its trajectory.
We sent the Cassini spacecraft to fly very, very close over these cracks where the water was rushing out.
Scientists clung to the faint hope that the water would contain salts and organic molecules like ammonia, the building blocks of life here on Earth. Stunningly, Cassini's sensors tasted them all in abundance.
In that plume, there's organic material. It's not water, it's a soup. That's incredible. All the main requirements for habitability, energy source, liquid water, a source of biological nitrogen and ammonia, organic material, and the samples are coming up into space. There's a big sign, free samples, take one.
There could be life that could have evolved there. Now, we don't know, we haven't seen it, but the conditions there are as good there now as they were on Earth 3 billion years ago when life arose here.
The sensational realization that Enceladus may harbor life has sparked intense debate about future missions to find it. But it has a rival for those precious research dollars, because Saturn's largest moon, Titan, could also be home to life, bizarre life, and we may have already found it. More than 60 moons orbit the planet Saturn, but one dwarfs them all. Titan is a colossus, bigger than the planet Mercury. A thick orange haze hides its surface from our telescopes. And when the Cassini mission first peered beneath Titan's orange cloak, it revealed a world weirder than we could have ever imagined.
Titan is an amazing place, and of all the things going on around Saturn, Titan might be the most exciting of all.
Titan has mountains and deserts, rivers and lakes. Only the Earth can match it for geological diversity. But here, water ice takes the place of bedrock, frozen at 300 degrees below zero. And instead of water, the rivers on Titan flow with methane.
This is a place where it actually rains liquid methane, liquid natural gas. This liquid is filling up rivers and lakes.
This makes Titan incredibly special. It's only the second world in the solar system where we know there's liquid on the surface.
And like Earth, Titan has a thick, nitrogen-rich atmosphere. But instead of the oxygen we breathe, Titan's air is spiked with carbon-rich molecules that stain it a dull orange.
It's a soup of methane and ethane and propane and acetylene. The list of organic molecules is literally hundreds long that we've detected there.
Titan's complex cocktail of atmospheric chemicals intrigues scientists, but it also puzzles them, especially methane gas, which rapidly decays in sunlight. So even a billion miles from the sun, Titan's thick haze should have lifted long ago. A vast source of methane must be replenishing the orange smog. Before Cassini, scientists assumed the whole of Titan was covered in massive impact craters. Perhaps crater lakes filled with liquid methane were evaporating into the atmosphere, supplying the missing gas. Cassini carried a hitchhiker all the way to Saturn to help prove this theory. The Huygens lander parachuted through the clouds, snapping photographs as it fell.
As it went through the atmosphere, it took a huge amount of data and then landed on the moon itself and took pictures. When we first saw those pictures, it was life-changing.
There were no craters. It looked like flowing liquid had once shaped the landscape. But at the landing site, and as far as Huygens could see, that liquid was long gone.
Huygens landed in a spot almost identical to what we're standing on right now. If we look all around, we can see this bleak, barren landscape. We see pebbles and cobbles that have been rounded and smooth because they've come through river channels. We see plenty of those at the Huygens landing site. In addition to that, we see lots of sand.
The desert Huygens landed in is huge. It stretches all the way around Titan's equator, with 300-foot-tall dunes sculpted by the wind, just like they are on Earth. If the vast crater lakes weren't at the equator, they had to be at Titan's poles. Cassini scheduled a number of additional flybys to look for any signs of liquid.
One of the instruments on board Cassini is basically a radar gun. It shoots radar waves at Titan, and they get reflected back.
After 2 years of hunting, scientists finally got the signal they were waiting for.
One of the things it found is that near the North Pole of Titan were regions that were not reflecting radar. And that sounds a lot like liquid. Liquid absorbs that energy and doesn't reflect it back. Later observations clinched it.
When Cassini finally imaged the north polar regions of Titan, it finally saw these lakes and seas of methane that we'd been looking for. Only they weren't contained in impact craters like we thought. Instead, they're contained in big lake basins that look just like they do on Earth.
Basin lakes, like this one in Mono County, California, form in the depressions left from tectonic activity. These geological features on Titan could only mean one shocking thing. The moon was alive with geological activity.
If we were sitting on the margins of Kraken Mare, which is the largest sea that we see on Titan, then we would probably see something very similar to this landscape. We would look out across a fairly calm surface. We think the winds are not very strong on Titan, and so we'd have this calm lake of methane and ethane. And in the distance, we would see hills and mountains that have formed on Titan, probably through tectonic processes in much the same way that mountains are built on Earth.
Except on Titan, it's so cold that volcanoes spew water, not lava. And the mountains and lake basins are solid ice. At first, scientists thought that methane evaporating from these lakes generated Titan smog. But when Cassini flew by to measure the lakes again, the levels appeared to be the same. The lakes didn't look like they were evaporating at all. Scientists were stumped. Either the lakes weren't the source of the atmospheric methane, or they were somehow being refilled. Planetary geologist Janie Radabau believes a crucial clue to the missing methane lies in the formation of rocky deposits called tufa. They're found here at Mono Lake, where clean spring water rises up from the ground into the mineral-rich lake, and the two water types react.
This is very exciting because this could be a clue to the missing methane on Titan. So it's rock that has been formed from the chemicals contained in two fluids. There is water that's emerging at the margin of the lake. It's interacting with the lake water, which has a very different chemistry, and all of the chemicals that are dissolved combine with each other and create this rock.
Radar images of Titan's largest lake reveal rocky structures around the margins that look just like Mono Lake's tufa. Titan's tufa, if that's what they are, could be evidence of a layer of liquid methane that sits above Titan's frozen core and rises in springs to feed its lakes. just like spring water rises to feed Mona Lake.
So when those methane springs come in, they interact with the lakes and rock precipitates out. So we see these organic rocks dotting the margins of the lakes. And almost certainly there's also methane just bubbling up and emerging at the margins of the lake as well.
If Janie is right, Titan's lakes do evaporate, feeding the atmospheric smog, but they're constantly replenished by underground methane springs replacing the lost fluid. Titan is no dead world. It's alive with active geology and complex chemistry. And it might be alive with something else, something big. We used to think that Saturn was too far from the sun and too cold to play host to anything dramatic. We couldn't have been more wrong. The planet boils and bangs with active weather, storms, lightning, and auroras. The rings constantly evolve. And the moons aren't the frozen snowballs we expected. They're shaped by active geology, with warm water geysers and lakes of liquid methane. And now, on Saturn's largest moon, Titan, scientists may have uncovered the first tangible evidence of extraterrestrial life.
Our search for life has been focused on liquid water. Follow the water. I think it's a good strategy. But I think we are limiting ourselves if we think that that's the only place to look. I think liquids may be interesting even if they're not water.
Astrobiologist Chris McKay believes that life on Titan may have evolved to live in liquid methane, not liquid water. But Titan's so cold, simple life would play by a different set of rules, where bigger is better.
When we go to other worlds, we're going to be looking for bacteria, and we assume that they're going to be very small. But you could ask the question, why are bacteria so small? Well, I think the answer is because they live in water.
On Earth, bacteria don't need to grow big to thrive. Water dissolves almost everything, so it provides a nutrient-rich environment where small and simple brings success.
We go to Titan, where the liquid is liquid methane, liquid ethane, very different from water. There's no reason an organism should be small. In fact, quite the opposite, it should be huge.
McKay envisions enormous single-celled organisms looking like sheets of paper. Their huge surface area would maximize the uptake of food from the nutrient-poor liquid methane.
I predict that there's life on Titan living in liquid methane. You won't need a microscope to see it. You'll need a yardstick.
When Cassini released the Huygens probe high above the cloud tops of Titan, McKay realized he had an opportunity to bolster his theories of life on the surface. His methane-loving life forms must be eating to survive. Perhaps Huygens' delicate sensors would pick up evidence of ground-level feasting.
As Huygens was on its way to Titan, I'm sitting in a hotel room writing up a paper saying, hey, what if there's life on Titan? What would it eat? And how would we detect it? How would this probe flying through the atmosphere detect it? Literally the day Huygens landed, I submitted this paper to the journal, predicting that if there was life on Titan, it would eat hydrogen, and the probe would be able to measure this depletion in hydrogen. So let's look for hydrogen.
Huygens parachutes through Titan's atmosphere, sampling the gases as it goes. The upper atmosphere has plenty of hydrogen, so do the middle layers. But at the ground level, there's a surprise result: an apparent drop-off in the concentration of hydrogen in the air. Something or perhaps someone was using it up.
When I heard a report that there was a depletion of hydrogen, my heart raced, because I thought, if this is hard data for depletion of hydrogen, I can't imagine any other way besides biology to explain that. It's exciting in that it's consistent with what we predicted, but we have to wait for this to be confirmed by other calculations, by direct measurements, and so on.
If future missions can confirm methane-based life on Titan, it will surely be the greatest discovery in the history of science, because this low-temperature biology must have arisen independently of life on Earth.
If we discover life, let's say, on Mars, there will always be the possibility that rocks and ice and bits of material could have been exchanged. But the chances of that happening from Earth all the way to Saturn are next to nothing.
If we find a second example of life in our solar system, especially in a place like Titan, which is so alien to the Earth, so cold and so different, that tells us something excruciatingly important, and that is that life must be everywhere in the universe.
Robotic missions offer tantalizing hints of simple life on Enceladus and Titan. But is Saturn's realm only fit for giant bacteria? Or is it a place we humans could one day call home? Saturn orbits 1 billion miles from the Sun, so far out that it takes an hour for its reflected light to reach our eyes. Yet the future of our civilization may rest on humans one day colonizing the moons surrounding this gas giant planet. It won't be easy, but Saturn has something worth the trouble. A magical source of fuel called helium-3 that could satisfy our increasing hunger for energy for millions of years.
Some futurists believe that we have to have a commercial incentive to going to Saturn, not just to mine the minerals of the moons of Saturn, but also to harvest fuel in the form of helium-3. Helium-3 is a rare substance that we could use in fusion engines to provide perhaps unlimited energy.
Helium-3 is uniquely suited to a form of energy production called fusion. The same process that burns in the heart of a star. When two nuclei are crushed together under enormous pressure, they fuse, creating a new, heavier atom and a burst of pure energy. Best of all, helium-3 doesn't release any of the harmful radiation associated with other fusion fuels. The only trouble with helium-3 is that there's precious little to be found on Earth.
Now, you can find some helium-3 on the moon, but the major supplies of helium-3 in our solar system are located in the atmospheres of the giant planets. I call the gas giants the Persian Gulf of the solar system because they are the location of its primary energy resources outside of the sun.
The gas giants provide a near inexhaustible supply of helium-3, but how could we extract it? Jupiter has the most, but the planet's immense gravity and dangerous radiation belts make it a no-go for mining. Neptune and Uranus are way too far away to be practical. That leaves Saturn, with relatively low gravity for such a big planet and far lower levels of deadly radiation than around Jupiter.
If we're going to have a future human economy based on using controlled fusion and helium-3, Saturn is the destination of choice.
Futurists envision winged drones flying through the upper atmosphere of Saturn, scooping up gases. But where to process this super fuel? The ideal base of operations would clearly be Titan. With gravity as gentle as our moon's and a thick Earth-like atmosphere, Titan is surprisingly suitable for a human outpost.
We could have huge dome settlements on Titan. They would not have to be strong enough to hold pressure. They could just be thin, inflatable membranes. You could have dome cities like you see in science fiction, which are really not possible in places like the moon.
Walking out onto the surface of Titan would be much easier than on the moon or on Mars.
The pressure on Titan is kind of nice. It's 1.5 times Earth pressure. You would need a source of oxygen, and you need a very warm coat. But it wouldn't feel as cold as you might think, because the atmosphere is calm and there's not strong wind. I think a coat like you might wear in Antarctica might be adequate. So you can imagine somebody stepping out of the spaceship, having a parka on, a mask like a scuba mask to provide oxygen, and literally walking out on the surface.
Titan's low gravity and dense atmosphere could even send us soaring from place to place.
Let's say you had, it's a little bit of a wing on your arm, and you started to flap your arms. Remember, it's almost like you're on the moon, but with a thick atmosphere, and you'd really be able to lift yourself off the surface, maybe fly just a little bit.
When the helium-3 trade route has opened and the Earth becomes a fusion economy, a new generation of rockets will open up interplanetary travel to everyone, taking humans to Mars and Jupiter in months, not years. And helium-3 might even power adventure tourism to Saturn itself.
You can imagine in 100 years when space travel is easy and there will be hotels orbiting the moon and Mars and everything. What would be the one? What would be the place, right, to go? It would be Saturn.
I would hope one day that there is such a thing as space tourism and people can visit places like Enceladus. This should be called the Enceladus Interplanetary Geyser Park because it would be a phenomenal place to just go visit.
Standing on Enceladus would be an amazing sight. All of this frost condensing back out on the surface makes it incredibly brilliant white. It's got some of the best powder snow for skiing anywhere in the solar system.
You could get close enough to actually see the individual rings. Maybe even see the little moons in the gaps, sculpting and pulling and pushing and prodding, shepherding those ring particles around. You could go back over and over again, and it would always be alien and exotic and exciting.
From a cold, dead jewel in our telescopes to a place alive with magic and mayhem, Saturn and its worlds have come alive and may harbor life itself. Someday soon, this planet could remake our universe, and nothing will ever be the same.